Hello folks, welcome back to another video on my YouTube channel. Today we are looking at another problem called find minimum in rotated sorted array. This problem we are given an input array called nums, and that array is rotated after being sorted. For example, in the first example, my array was 1 2 3 4 5. After rotating it 3 times, it became 3 4 5 1 2. Then in the second example, my array was 0 1 2 3 4 5 6, and after rotating it 4 times, it became 4 5 6 7 0 1 2. Similarly, in example 3, my array is 11, 13, 15, 17, and this has been rotated 4 times, so it became the same array again. Now we are supposed to return the minimum element of this rotated sorted array. So for example, here the minimum is 1, here the minimum is 0, here the minimum is 11. We're given that the length of the array is 5000 at max, and the numbers are from minus 5000 to 5000. We're also given that all the integers are unique in the array. Now let's see how we'll solve this problem. The one thought that comes into our mind is to use binary search to solve it in O of log n time. But a simple binary search won't help us here because the array is not sorted now after rotating. It becomes unsorted. So now let's say I have a normal approach where I take these two original input example and I use that to demonstrate what my solution approach is. So let's say I have L and R pointers pointing to the left and right ends of this array. And what I want to do is find mid now. So mid will be 5. And the most uh, obvious approach one could use is finding this inflection point that we have here. We see that whole array is increasing. So 3 to 4 is increasing, 4 to 5 is increasing, 1 to 2 is increasing. But from 5 to 1 it is decreasing. So that means this point is the inflection point and the number after the inflection point should be the minimum. But I'm not going to do that. Instead, I'm going to use another approach where I take result and I'm going to iterate this array in such a way that I find all the values that could be in the result and find the minimum of those. For example, I have uh, 3, 4, 5, 1, 2. Mid comes out to be 5. So I know that 5 could be one of the answer. Okay. Now, if 5 could be one of the answers, I'll add that to rest. But now I want to divide my solution into two parts. So one is this and one is this. So how do I know where do I move? Do I move on to the right end of this array or the left end of this array? How is that determined? So that will be determined by seeing that if array L is less than equal to array mid. If this is true, what that means is that this part is sorted. So that means my answer is on the right side of the array. Now, how can I say that? For example, the answer was 1, 2, 3. Now, when I rotate this array, the bigger numbers would come onto the left side of this. So 3, 1, 2. Now, if I find uh, the left side to be sorted, that means the smaller numbers are naturally be on the right side. Okay. Now, let's do that. So if left half is sorted, that means I want to search on the right side. So that means I'll do L2 mid plus 1. Otherwise, I'll search on the left side. Okay. Now once I do that, my search space reduces to this 1, 2. And I'll also need to add another base case that if array L is less than equal to array R, that means my whole array is sorted, which I'm considering right now. And in that case, I'll just change rest to array L and I'll break. Otherwise, I'll keep finding minimum mids as I go on in the answer. So now L will become mid plus 1. So this will be my search space. Now when I compare L and R, 1 will be, this is sorted now completely. So that means 1 is my res now. So I'll assign res as 1 and I'll just break the loop. So this will be 1 and that will be my answer. Let's also consider one more example here. So let me take blue color pen this time and let me take a larger example now. So let it be 2, 3, 4, 5, 6, 7, 1, or sorry, 0 and 1. Let me write the indices real quick. And now if you see, the mid will come out to be 7 by 2, 3. So mid will come here, L is here, R is here. I see that the left part is sorted, so that means my minimum will be on the right side. And I will also write res here. So res is 5 for now because that is the mid element. Now I change my search space to this. So this is L now. This is gone. Mid will come out to be 7 plus 4, 11 by 2, which is 5. And here I get 7. So 7 will be res, but as we have a smaller value before, so this will be ignored. After that, what do? I check that this half is sorted. So that means again I need to change mid to L to mid plus 1. So this will become L now and this will become R. And now we find that this array is sorted 0, 1. So that means this is my answer now and this becomes 0. Now let's see how we'll code this problem. Now I'm given a function called findMin with an integer vector called nums. Let's start with the approach we discussed. So L will be 0 and R will be num.size minus 1. We also have a rest variable, initially let it be num0. And let's start with our approach. So while L is less than equal to R, I'd find if the whole array is sorted. So if whole array is sorted, that is array L is less than equal to array R. In that case, what did we discuss? Array L will be the answer. So rest will be minimum of array L and this. So, and I'll break this loop. And at the end, just return this. Okay, the array is named nums. So instead of R, just use nums here. Now I'll check if the left half of the array is sorted. So array L is less than equal to nums L is less than equal to nums mid. So that means my left part is sorted. So I need to move to the right to find the minimum value. So L equals to mid plus 1 I'll do here. Otherwise I'll do R equals to mid minus 1. I need to find mid here. So mid will be L plus R by 2 and also use mid as my rest. So our rest will be min of s comma mid, nums of mid. That should be it. Let's try running it. Okay, input test cases are working. Let's try submitting. So as you can see, my solution is working. Thank you for watching. See you in the next video. Till then, happy coding.